Rate, whether you're in maths or science, refers to something being over the change of time. For this, because we have the change of something over the change of something else, we therefore, in rates of change questions, are going to be dealing with differentials, specifically with something over dt, where this top variable can just be whatever the question is asking for. So you're going to have a scenario that you'll read through. There may be a diagram or it may just be text, and you need to identify which differential expressions do you have or which ones can you work out. And using these, you're going to have to make another differential, which is what the question is asking for. Now, the reason why you may not have what the question is asking for immediately is, let's say that it was asking for dy over dt. However, in your question, you don't have an equation of y in terms of t, you have y in terms of x. So when you differentiate it, you would get your more traditional dy over dx. So how do we turn this into a dy over dt? Well, somewhere else in the question, there will be another differential, perhaps hidden more in a statement rather than an equation that you can differentiate. And this statement would, in this case, get you dx over dt. Now, if you were to multiply these two differentials together, you would have your dy on the top here and the dt on the bottom. And then the fact that you have dx in the numerator here and dx in the denominator here would cancel, leaving you with the dy over dt that you're after. So the key here is that once you have identified all of your differentials, you need to work out in what order and which way up do you need to combine them together so that you will cancel and leave yourself with your desired differential, and then you can just do the appropriate equivalent things with the actual expressions. For an example of this, we could have that water is flowing into a vase with a circular cross-section. When the depth is h centimeters, the volume is given by V equals 4 pi h, and then in brackets h plus 4. Water flows in at a rate of 80 pi centimeters cubed per second. Find the rate of change of depth when h is 6. Okay, as I say, as we go through this, we're just going to try to identify any differentials that we could possibly get, either that were already given or that we could make. The first instance of an equation that we could use is the volume equation here. So what we might want to do first of all before differentiating is just expand the brackets here. So we can get that V equals 4 pi h squared plus 16 pi h. And from that you would get dv over dh, because V is on the left and h is on the right. So that would differentiate to 8 pi h plus 16 pi. Okay. And then what else do we have? So the water flows in at a rate of 80 pi centimeters cubed per second. Well, if we're not sure exactly what that refers to, centimeters cubed is going to be volume, and per second will be over time. So we have here a dv over dt having a constant value of 80 pi. And then find the rate of change. Okay, so we're at the end of the question now. We have nothing else that's given to us. That's okay. What we'll just identify here then is that we are trying to make dh over dt, the rate, so over dt, of the change of the depth. And the depth is given by h, so change in h. So how can we combine these two differentials here to make this? Well, we want dh on the top. So what we're actually going to have to do here is flip this differential on its head, get the reciprocal of it. So it'll be dh over dv, and this will be times by the dv over dt, because that gets the dt in the denominator, and also now those dv's would cancel away algebraically. Here, your dh over dv, so the reciprocal of this, is just going to be 1 over the 8 pi h plus 16 pi, so you're timesing that by the 80 pi, and together the pi's are going to cancel. And you can also then cancel through by a factor of 8. So 8 disappears here, the 16 would become a 2, and the 80 would become a 10. This then is your expression for the rate of change in general, so it'll be 10 over h plus 2, but we're after it when it's specifically h is 6. So we'll say that dh over dt equals 10 over 6 plus 2, which would simplify to 5/4 centimeters per second. Alternatively, you may also have something like this, where a cylindrical water tank has a diameter of 6 meters. Water is flowing into the tank at a constant rate of 0.48 pi meters cubed per minute. Now, at time t minutes, the depth is h meters. There is also a tap letting water out at 0.6 pi h meters cubed per minute, though. So therefore find dh/dt. So the difference here, other than also time is now minutes and seconds, is that not only do you have the volume increasing at one end, it's also trying to decrease at the other. Therefore, because both of these changes in volumes are already rates, they're already over dt, so we'll just say dv/dt, you would have an increase of 0.48 pi, but then at the same time, a decrease, a minus of 0.6 pi h. So that together would give overall what the rate of change in volume is at any given height. We also need some other differential though in order to help us get this dh/dt. So they haven't given us any equations, but they have told us that this tank is cylindrical. So if we just think about how we could potentially relate a cylinder's volume to its height, its depth, that would then be able to be differentiated to give a dv/dh. So the volume of a cylinder is pi r squared h, which in our case here is going to be r is going to be 3, because if the diameter is 6, the radius is half of it. So 3 squared is 9, so 9 pi h. Therefore, dv/dh is going to just be 9 pi. Therefore, in an attempt to times them together to make the dh/dt, we're going to need to put dh on the top. So we're going to be flipping this one, so dh/dv, and then we'll times that again by the dv/dt. So in this respect, it's actually the same as the previous question from this point on. When you flip this, that's going to become 1/9 pi, and you'll times that by the 0.48 pi minus 0.6 pi h. Once more, the pi's can cancel, leaving you with just 0.48 minus 0.6 h over 9. Now, it may be that you'd rather not have decimals in the numerator, either because the question is specifying it or just your own personal preference. That's fine. You could now just try to rewrite this fraction, just remembering whatever you do to the top, you have to do to the bottom. So you could times both top and bottom by 100 to get you 48 minus 60h over 900, and then you could start cancelling down by the factor of 3 or 2 or so forth. And if you were to do that, you could end up just with 4 minus 5h over 75, if you so wish. Okay, if you're happy with that, we can see then how we can take these descriptions to create some d something over d something, and how we can then combine these differentials to make the differential that we're truly after. Let's just see how you could get along with an example of your own. A sphere's volume and surface area are given by V equals 4/3 pi r cubed and S equals 4 pi r squared respectively. Given that the rate of decrease in surface area is minus 12, find dv/dt. So, you have a differential that you need to find, you have some equations that you can work with, as well as a statement mentioning rate. Pause the video, have a go for yourself, maybe just think back on the examples we were just doing if needs be, and then press play again when you're ready to compare. Okay, so first of all, what we'll probably want to do is just differentiate these two equations each, just to be sure of what differentials we do have to work with. This first one here would differentiate to be dv/dr, and so the 3 times the divided by 3 is going to cancel, leaving us with just 4 pi r, and then the power will drop to 2, and then the second equation will become ds/dr, which is going to differentiate to 8 pi r. As for this statement here, given that the rate of decrease in surface area, okay, well, the surface area was S, so that's going to be a ds, and it's the rate, so that's over dt, that's going to equal apparently just minus 12 here. Now, how to combine any of these three to make the dv over dt? Well, we need a dv on top. So we have to have this dv over dr here, that way up, because it's the only thing that contains dv. However, we also need a dt on the bottom. The only dt we have available is the ds over dt here. But what this has left us with is a dr we don't want on the bottom and a ds that we don't want on the top. So finally, we're also going to have to times by dr over ds, the reciprocal of this differential here. So again, just to spell it out, that would then be 1 over 8 pi r. This together then would have, as I say, the dr cancels with the dr here, ds cancels with ds here, leaving us algebraically with just a dv over a dt. So the dv over dr was the 4 pi r squared, and we're going to times that by the minus 12 for the ds over dt, and then that is going to be divided by the 8 pi r, because we're timesing by 1 over it. Well, on the top, that would just lead essentially to minus 48 pi r squared over 8 pi r. From here, the pi's will cancel as such. This r will cancel with one of the r's from up here, and this 8 will cancel with this to leave us with a factor of 6. Therefore, your dv over dt, your rate of change of volume for the sphere, is represented by minus 6r. Okay. If we're happy with that, let's then just look to one further question. A circular stain grows in such a way that the rate of increase of its radius is inversely proportional to the square of the radius. Given that the area of the stain at time t is a centimetre squared, show that dA over dt is proportional to 1 over root a. So, for this question, we are now dealing with things being proportional to rather than just equal to. So we're going to have this symbol here in the middle rather than an equal sign. And similarly, just when we say that something is inversely proportional, just as a recap in case we're not entirely sure, if y was inversely proportional to x, that would mean it's proportional to 1 over x, because as x gets bigger, we're dividing by a bigger number, so the value of the fraction gets smaller, y gets smaller. So x is bigger, y is smaller. But if x got smaller, you're now dividing by a smaller number, so the fraction gets bigger, y gets bigger. So as one goes up, the other goes down, basically. To make this an equal sign, though, if you were wanting to, you could say that that would be y equals k over x here, where k is some constant value that you would find. So, in this case, because we're dealing with a circular stain and we're going to be dealing with area, we'll probably want the area of a circle, which is just going to be our pi r squared, which, again, because of the nature of the question, we're going to want to differentiate. That would give us dA over dr, which will be 2 pi r. We're after dA over dt though, so as before, we'll have to now find another differential, so we'll look to the statement. So we're saying that the rate of increase of the radius is inversely proportional to the square of the radius. So the rate of increase of radius will be dr over dt, and we're saying that this is inversely proportional to the square of the radius. Now, you can either do this, where you simply say that it's proportional to 1 over r squared here, or you can write that dr over dt equals k over the r squared. Whether you prefer to use just proportional already, or you would prefer to add in another unknown constant and keep it equal sign for now. Either way, to therefore make your dA over dt, we are going to be having our dA over dr times by the dr over dt. It is therefore just a matter now of, if you took the first option, you would be writing this as dA over dt is already just proportional to the 2 pi r times by 1 over r squared, or you would be writing that dA over dt equals 2 pi r times 2k over r squared. In either case, then that'll either be proportional to 2 pi over r or equal 2 pi k over r. Now, as we notice though, we're looking for a root of a to be what the denominator is, not r. So we're now actually going to have to turn our attentions back to the original equation to do a bit more rearranging. If we wanted to make r the subject, what you'd be doing is you would be dividing the a by the pi, to get that away from the r squared here, and then to turn the r squared into just a singular r, you would be square rooting. So r equals the root of a over pi. Therefore, we can now make that substitution here. So this will be proportional to 2 pi over root a over root pi, because if you have a square root of a fraction, just as how you can split up the square root of a multiplication into two separate square roots together by how you do surds, you can do the same with a fraction. So it's just, this is the same as the square root of a over the square root of pi, or here this will be 2 pi k over, again, square root of a over square root of pi. Now in both cases here we have a fraction within a fraction. In this case that mini fraction is in the denominator, so we can bring its denominator up into the numerator. So we'd have proportional to 2 pi root pi over the root of a, or equals 2 pi root pi k over root a. Now, if you're already in the proportional section, all we can say is, well, the 2 pi root pi is already a constant, and constants don't need to be accounted for in expressions of what proportion is, if you're using the proportional symbol. So it's the difference between proportional as 1 over and equals as a constant over. So again, it's just the same as being proportional to 1 over root a. And then by the same principle, again, 2 pi root pi k, they're all constants. So that numerator, once again, is constant itself. Therefore, we're saying that this dA over dt just depends on what the root of a is down the bottom. Therefore, once again, you end up with this just being proportional to 1 over the root of a, and you have shown your answer.